You've probably seen it in your kitchen cabinet or at the back of an old recipe book. The Three Gorges Dam is so massive, you've drizzled it on salads, massaged it into your hair, maybe even pampered your skin with it. Avocado oil is everywhere. But have you ever wondered how this green tropical treasure turns into liquid gold? Let's take a closer look at how avocado oil is made, step by step. The journey for the extraction of the oil begins with the cultivation of avocados, which are native to Central America and thrive in subtropical to tropical climates such as Mexico, California, or Florida. These regions offer the perfect blend of warmth, sunlight, and well-drained soil. Peak harvesting season varies by region. Mexico's main harvest runs from October to February, while California picks up in spring. The first step in the process is harvesting the fruits from the avocado orchards. This is done by hand rather than by machine to avoid bruising. After harvesting, they are transported to the plant for further processing. The selection process is very precise as each avocado is examined by hand to find the best of the lot with the perfect balance of firm yet yielding, a rich, consistent color with no signs of blemishes or mold. Why such precision? It's because only healthy and perfectly ripe avocados have the highest oil content and the best flavor. There are many varieties of avocado worldwide, but here's an intriguing question. Which variety of avocado is the most used when it comes to oil production? Comment with your guesses below and we will reveal them at the end. Upon arrival at the processing plant, all the avocados embark on their first cleanse. Since the oil is used in both food and skincare, maintaining strict hygiene at this stage is crucial. They undergo a thorough washing to remove all sorts of dirt, dust, pesticides, or other contamination through a specialized washing machine with high-pressure water jets equipped with rotating soft bristle rollers and spray bars that ensure even hard-to-reach crevices are cleaned. Following the initial rinse with water, some plants and facilities take an extra step, using food-grade sanitizers which are designed to kill all strains of bacteria or other harmful pathogens. Next up is the de-pitting and de-skinning of the avocados. They're moved to cutting machines that slice them in half. Then, with the help of innovative mechanisms, the large central pit and tough outer skin are removed. What's left is the prize, only the vibrant pulp. The greenish-yellow pulp is then collected to make the final product, the oil. Did you know that unlike other oils such as olive oil, avocado oil is only extracted from the pulp or flesh of the fruit? Once collected, the next step is to grind the avocado pulp into a soft paste, just like guacamole but without the seasonings. This is not your kitchen blender. We are talking about industrial-grade precision. High-capacity industrial grinders are used to break down the pulp into a smooth green paste of creamy consistency, which is stored in a large stainless steel container before going to the next step, malaxation. The grinding process typically takes 10 to 20 minutes, depending on the batch size. There are different approaches to extracting the oil after the paste is made. The most popular is mechanical extraction, which uses pressure to squeeze the oil out from the paste. This is where it gets interesting. The paste is transferred into a specialized tank called a malaxer, which slowly stirs the paste for 30 to 60 minutes at a warm temperature of 113 to 122 degrees Fahrenheit. These conditions are scientifically calculated to be just right, warm enough to allow oil separation without degrading the paste. Malaxation helps tiny or microscopic oil droplets blend into the larger droplets, making it easier for the oil to separate from the pulp in the next step. Some producers experiment with inert gases like nitrogen during this step to reduce oxidation even further. This method, performed under strict conditions, is what defines cold-pressed extra virgin avocado oil, which retains nutrients, flavor, and color. While expeller-pressed methods use higher temperatures, which often leads to higher oil content but lower nutritional quality. Next in the process, we have centrifugation, which, as the name suggests, uses centrifugal force, the same force that pushes you back in your seat on a roller coaster, to separate certain particles from a solution. The mixture after malaxation is positioned in a centrifuge, a machine which uses high speed to separate the oil, water, and solid pulp. Industrial centrifuges can spin at speeds of up to 6,000 RPM, faster than the turbines of some jet engines. As the centrifuge bowl spins at thousands of revolutions per minute, the heaviest component in terms of density separates and accumulates against the inner wall of the spinning bowl, and our desired component, i.e., the oil, accumulates near the center of the spinning bowl. This mechanical brilliance uses absolutely no chemical solvent, leading to the production of a pure and organic final product like lutein and vitamin E. Even after the powerful centrifugation, our avocado oil is not quite ready to be bottled up. The oil may still contain minute particles of pulp or impurities. It undergoes filtration to remove any remaining contamination, leading to the final product being pure and of the highest quality. Filtration can be done in 2 steps to ensure the avocado oil is clean. Initially, a coarse filtration in which oil passes through a sieve-like mesh screen or cloth filter captures larger pulp particles. Meanwhile, a fine filtration process is used to remove fine particles using vacuum pressure or filter plates. After filtration, the oil must be in its purest form. To confirm this, extensive testing is performed to ensure it meets the required standard for quality. The test not only solidifies that the oil is safe and healthy to consume, but it checks everything from acidity and freshness to water content, color, and clarity. After all, in a market where avocado oil sales are projected to exceed $800 million globally by 2030, quality is not just a standard, it's a competitive advantage. After all these tests, the oil is labeled accordingly, either as extra virgin, virgin, or refined oil. For example, extra virgin avocado oil must have an acidity of less than 0.8%, a bright green hue. Now that the oil has passed all the quality tests, it is ready for its final destination, the bottle. Most avocado oils are packed in dark green bottles to protect against UV light, which can degrade the oil over time, but first, all bottles undergo a thorough sterilization process with high-temperature washing and air drying. The filtered avocado oil is then poured into the sterilized bottles using automatic filling machines with precision to dispense the exact quantity in each bottle. These machines can process 5,000 bottles an hour. Nitrogen gas is also used to push out any air from the top, preventing early spoilage and extending its shelf life. Finally, each bottle is sealed tightly with a cap and moved to the labeling station, where machines stamp the brand name, harvest date, expiration date, and its grade, whether it is extra virgin, virgin, or refined oil. The oil's now ready. Bottled and sealed, now it's time for it to make its way to you. They are carefully grouped in packs of 6 or 12 to be packed into durable cardboard boxes for storage and transportation. Once packaged, the oil may be stored in refrigerated containers and shipped across continents, from the highlands of Mexico to kitchens in Tokyo or Toronto. From the orchard to the bottle, we just dissected how avocado oil is produced. However, its origin has a far more ancient and fascinating past. The avocado fruit itself has ancient history in Central America, and the extraction of its oil can also be traced back to ancient civilizations such as the Aztecs, but mostly for cosmetic uses. Surprisingly, it was not until the 20th century that the production and consumption of high-quality, cold-pressed culinary avocado oil gained popularity. It really began gaining traction in the late 1990s and early 2000s, mainly pioneered in New Zealand, where producers perfected the method of gentle extraction to maintain its natural flavor, color, and nutritional benefits. The next time you enjoy avocado oil, think about the journey behind it. From a vibrant fruit in the orchards of Mexico to the versatile staple in many salad dressings. And as for the question from step 1, which variety of avocado is the best for oil production? The answer is Hass avocados, primarily due to their high oil content, ranging from 18 to 23% in creamy texture, adding to the superior flavor.
Take a look around your kitchen. Chances are you have a bottle of vegetable oil sitting on a shelf, ready to help you fry, sauté, bake, or dress a fresh salad. It's in crispy golden fries, fluffy cakes, and even some of your favorite sauces. But have you ever stopped to wonder, how does oil, something so liquid and smooth, come from tiny, dry seeds? Today on Products Uncovered, we're cracking open the story behind vegetable oil, how it's made, the science that goes into refining it, and why it has become one of the most essential ingredients in kitchens worldwide. Here's something to think about. Which vegetable oil is considered the oldest in human history? Stick around to the end to find out. Step 1. Sourcing and harvesting. Vegetable oil refers to any oil that comes from plants. A variety of plants, including soybeans, sunflowers, canola, and palm are used. Each crop is carefully cultivated and harvested at peak maturity to maximize oil content. For example, soybean oil accounts for nearly 28% of global vegetable oil production, making it one of the most widely used oils in the world. Each crop has its own demands. Sunflowers stretch toward the sun, their heads physically rotating to absorb as much light as possible. Canola thrives in cooler climates, developing high oil seeds when temperatures drop at night. Palm oil comes from the dense tropical plantations, where towering trees bear bright orange fruit clusters packed with oil. In soybean and canola fields, high-capacity combines sweep through, stripping seeds from stalks while onboard computers analyze moisture levels in real time. Palm oil harvesting, in contrast, is a manual skill perfected over generations. Workers climb tall trees with razor-sharp machetes to hack down fruit bunches, some weighing over 100 pounds. The fruit must be processed within 24 hours, or the oil quality starts to degrade. Once gathered, the seeds and fruits are loaded onto conveyor belts and hauled to processing facilities, where quality control begins. Infrared scanners and high-speed sorters remove defective seeds, ensuring only the highest-grade raw materials move forward. Even at this early stage, oil purity is a priority, because once an impurity enters the system, it's nearly impossible to remove completely. This process is fascinating, right? If you're enjoying this so far, don't forget to hit that like button and subscribe for more behind-the-scenes looks. And tell us in the comments, which type of vegetable oil do you use most in your kitchen? Step 2. Seed preparation and conditioning. Before extraction begins, seeds undergo rigorous preparation to maximize oil yield and purity. Inside massive processing factories, conveyor belts transport seeds through a series of automated cleaning systems that remove dirt, stones, plant debris, and even metal fragments using air classifiers, sieves, and magnetic separators. Next, industrial dryers reduce moisture content to prevent spoilage. Soybeans, for example, are dried to around 10% moisture, ensuring they don't ferment or become too brittle. After drying, dehulling removes outer shells, which contain little to no oil. Factories use impact hullers for sunflower seeds, while canola seeds are simply crushed. The removed hulls are repurposed as livestock feed or biofuel. For some seeds, an additional flaking process is required. Large steel rollers press the seeds into thin flakes, increasing surface area for better oil extraction. Precision moisture sensors adjust rolling pressure in real time, optimizing efficiency. This entire process is fine-tuned for high efficiency and minimal waste. By the time the seeds reach the extraction stage, they're in prime condition, ensuring maximum oil recovery in the most efficient way possible. Step 3. Oil extraction. Oil extraction is the heart of vegetable oil production. There are two primary methods used: mechanical processing and solvent extraction. Each method has its advantages, and the choice depends on the type of seed being processed. The first method, mechanical pressing, uses a screw press that applies extreme pressure to crush the seeds. As they're squeezed, oil seeps out and is collected in stainless steel filtration tanks. This method is often used for oils like olive and sesame, where retaining natural flavors is a priority. However, some oil remains trapped in the leftover seed meal, making this process slightly less efficient. To recover nearly all the oil, large-scale factories rely on solvent extraction. Here, crushed seeds enter an enclosed extraction chamber, where they're soaked in hexane, a food-grade solvent that dissolves the oil. The oil-laden solvent is then heated in industrial distillation units, evaporating the hexane, which is later recycled and reused. What's left behind is nearly 99% pure crude oil, which is piped into storage tanks for further refining. After extraction, the remaining solid material, known as oil cake, is rich in protein and is often repurposed as animal feed or fertilizer. The crude oil, however, still contains impurities and must undergo further refining to become suitable for consumption. Step 4. Refining the crude oil. At this stage, the oil may look ready, but if you were to taste or smell it, you'd probably change your mind. Crude vegetable oil is cloudy, sometimes bitter, and carries unwanted impurities. Not exactly what you'd want in your salad dressing. That's where the refining process comes in, transforming it into the clear, neutral oil we use every day. First, the oil undergoes degumming, where water or acid is added to separate out phospholipids and gums, which can cause cloudiness and spoilage. Then comes neutralization, where sodium hydroxide is used to remove free fatty acids. This reaction forms soap, which is later spun out in high-speed centrifuges. Next up, bleaching, but not the kind used for clothes. The oil is passed through natural clay or activated carbon, filtering out unwanted pigments and impurities, ensuring that perfect golden hue. But what about the smell? That's handled in deodorization, a high-temperature steam distillation process that strips away any lingering odors, leaving behind a clean, neutral-flavored oil. At this point, the oil is clear, stable, and finally ready for the next step. Step 5. Winterization. Ever notice how some oils turn cloudy when stored in the fridge? That's because they contain waxes and saturated fats that solidify at lower temperatures. To prevent this, certain oils like sunflower and soybean oil undergo winterization, a refining step that ensures they stay clear and pourable, even in cold conditions. Here's how it works. The oil is slowly cooled to around 40 degrees Fahrenheit in specialized chilling tanks, allowing waxes and other solid particles to crystallize. These tiny solidified bits are then removed using fine filtration systems, leaving behind a perfectly clear, smooth oil. Without this process, salad dressings would look unappetizing, and gourmet oils could turn cloudy in colder climates. Winterization guarantees that whether it's in your fridge or on a store shelf in Alaska, the oil maintains its clarity and quality. Step 6. Bottling. Once the oil is fully refined, it moves to the bottling stage, a high-speed, highly automated process that ensures precision, hygiene, and efficiency. The first step involves prepping the bottles, whether they're made of PET plastic, glass, or even metal for industrial-grade oils. These bottles are sterilized using a blast of ionized air or a UV treatment to eliminate any potential contaminants. Next, the bottles move to the filling station, where a network of pneumatic pumps and servo-driven nozzles dispenses the exact amount of oil into each container. In high-capacity factories, some lines can fill up to 600 bottles per minute. Finally, the finished bottles are packed into crates, stacked on pallets, and sent off to warehouses. From there, they make their way to grocery store shelves and eventually to your kitchen. Step 7. Distribution and storage. Getting the oil to your kitchen is a massive operation. Vegetable oil is shipped globally in food-grade tankers, loaded onto trucks, and transported across thousands of miles. A single delay, weather, trade restrictions, or factory bottlenecks can impact prices and availability worldwide. Ever notice why oil bottles are often dark-colored or opaque? That's because manufacturers design packaging to block light exposure, keeping the oil fresher for longer. But once it reaches your home, the storage is up to you. Want to make your oil last longer? Keep it in a cool, dark place, away from heat and direct sunlight. It's easy to overlook, but every bottle of vegetable oil goes through an incredible journey. From farms to high-tech factories where seeds are crushed, spun, and refined into the golden liquid we use every day. Now, remember that question from earlier? Which vegetable oil is the oldest in human history? The answer is olive oil, dating back over 6,000 years. Ancient civilization used it not just for cooking, but also for medicine, skincare, and even fueling oil lamps. Talk about a multi-purpose powerhouse. Thanks for watching. Don't forget to like, comment, and subscribe for more fascinating deep dives. See you next time.